All right, day 3 of Earthquakes, Chapter 4, Lesson 2, page 146, Recording Seismic Waves. Red pen, capital R-E-C-O-R-D-I-N-G. Seismic, capital S-E-I-S-M-I-C. Waves, capital W-A-V-E-S. Switch to the pencil. When an earthquake strikes, scientists can quickly locate its origin and measure its strength. This is possible because of a huge network of instruments that monitor movement in Earth's crust. The network covers California especially well. Okay, locate, L-O-C-A-T-E, and down 3 down. Measure, M-E-A-S-U-R-E. Locate and measure. Seismographs are the main tool for measuring the strength and duration of an earthquake. A seismograph detects and measures the amount of ground motion during a quake. Scientists interpret these data to measure the strength of an earthquake, also called its magnitude. Okay, so a seismograph, S-E-I-S-M-O-G-R-A-P-H, seismograph, equals strength, S-T-R-E-N-G-T-H, plus duration, D-U-R-A-T-I-O-N. So you can use seismographs to locate or find where the earthquake started and measure it. The things we're measuring are the strength, how much energy it has, and the duration, how long it lasts. Magnitude, so I put quotes, M-A-G-N-I-T-U-D-E, close quotes, magnitude. A seismograph produces a written trace of seismic waves, called a seismogram. Data are recorded as lines on a drum or by a computer. So this whole machine in this picture is the seismograph. The piece of paper and the drawing that it produces, which ends up looking like this, only turned sideways, is the seismogram. And when they say lines on a drum, they don't mean a drum like a drum that you play in band. They mean a drum like a round turning drum. So that part is round and it turns, and a little needle draws these lines and the paper rolls out off of that drum. One type of seismograph measures horizontal motion. Okay, horizontal, horizon, the horizon of the earth, left and right, flat. It consists of a rotating drum attached firmly to the bedrock underground. Okay, so what they're saying is this round part is attached to the bedrock underground, while the rest of the machine is kind of attached to the surface. A weighted pin is suspended over the drum like a pendulum. Remember, a pendulum is like those clocks that have a pendulum swinging back and forth. The pin marks the paper wrapped around the rotating drum. Okay, so this drum is slowly spinning and rolling out the paper, and then the pendulum kind of like floats right on top of it and wiggles. So as an earthquake happens, that drum shakes back and forth and the pin ends up writing these lines. So as the paper goes out, it can shake, it'll shake more, and then it shakes a lot, and then the earthquake finishes. When a quake strikes, the drum attached to the bedrock moves with Earth's motion. The suspended pin does not move, so it traces the movement of the drum beneath it. Okay, so imagine that this piece of paper is the drum, and here's the pin. In reality, the pin's not moving, but the paper or the drum moves and shakes, and then that means that the pin is staying put, so it looks like it's drawing these wiggly, wavy lines. Seismographs also record aftershocks, which are smaller earthquakes that follow the first one. Aftershocks can occur for several days after an earthquake. Some aftershocks are destructive. Okay. Uses, U-S-E-S, pendulum, P-E-N-D-U-L-U-M, pendulum. Aftershocks, A-F-T-E-R-S-H-O-C-K-S. Aftershocks literally happen after the initial shock. Okay, now, the tricky part, drawing this picture. What we're going to be drawing is that little jolt right there and some tiny waves, bigger waves, and then massive waves, and then they get smaller towards the end. So on your piece of paper, you want to draw a little bit of a horizontal line, an initial jolt or shock, tiny little squiggles. Then this whole section here has some bigger squiggles. And then this section over here has really big squiggles that eventually get smaller. Okay, so you want that initial jolt, slightly bigger waves, and then the biggest waves that peter out over time. Okay, now we're going to label some stuff. So remember, the very first waves to show up are the P waves, and we're going to say pop, because if you feel an earthquake and you feel a sudden pop, that's what it is. So P waves, W-A-V-E-S, pop. P for pop. The next ones that come are the S waves. Remember, those are the ones like the jump rope waving up and down. So it's actually going to feel like a shake when you're on the surface of the earth. It feels like a shake. S for shake. So S waves, capital S dash W-A-V-E-S, shake. S-H-A-K-E, shake. So P waves, pop. S waves, shake. And then the last one is the surface, or L waves, and they roll. See, there are two letter L's in the word roll, so that's going to help us associate L with roll. L waves, capital L dash W-A-V-E-S, open parentheses, surface, S-U-R-F-A-C-E, close parentheses, roll, R-O-L-L. So you feel a pop and a shake, and then things start to roll, and that's where all the damage is caused. Okay, let's make sure we have all the notes we need to answer this question. In what order do waves appear on a seismogram? On a seismogram, the waves appear in the following order, colon. First, zoop, P waves, second, zoop, S waves, and last, zoop, L waves, or surface waves, And then we could go back and use the computer to add details, like how the P waves is kind of like the pop, the S waves are the shake, and then the L waves are the big roll that causes all the damage. All right, now let's go ahead and do phase 2. Phase 2 processing. Remember, processing means that we are going to highlight and annotate the key details that support the main idea. Okay, what is our main idea? Earthquakes equal sudden motion along faults. Okay, let's go ahead and highlight that. Highlight our main idea, earthquakes equal sudden motion along faults. All right, let's use the visual summary as a guide. Sudden movements along faults cause earthquakes. Okay, sudden movements along faults cause earthquakes. That's why we highlighted that. Anything else? How about down here at faults? Sudden arrow earthquake along faults. Okay. Rocks build up stress along moving plate boundaries. There's boundaries, and there's the stress builds up. Then suddenly release energy as they break. Okay, we already highlighted sudden. Let's highlight seismic wave and wave of energy, because we talked about energy just now. Seismic waves travel to the surface. Let's see, seismic waves travel to the surface. Surface waves, right there, surface. Okay, examples of seismic waves include P waves, S waves, and surface waves. Okay, so let's highlight P waves, S waves. We already have surface. Let's highlight the L wave. Each travels in a different way. Okay, so P wave, let's highlight longitudinal, like a slinky, going in and out. S wave, let's highlight transverse, like the jump rope, kind of going up and down. And then L wave, let's highlight rolling motion. And then use your red pen to add those words. Pop for P waves, shake for S waves, and roll for L waves. So pop, shake, roll. Okay, let's see, what else do we have? Surface waves often carry the most energy and cause the most damage. Highlight damage, exclamation point. Okay, scientists measure the strength of earthquakes by using a tool called a seismograph. So let's highlight our vocabulary word, seismograph. Let's also highlight it down here, seismograph. Okay, let's see, they say measure the strength of earthquakes. So locate and measure, highlight that. Strength plus duration, highlight that. The seismic waves appear as wavy lines that show how the ground is moving. I'm going to go ahead and circle our drawing because those are the wavy lines that show the pop, shake, and roll. All right, that's it for phase 2. So now for phase 3. First, something I know. Remember, the I know is not on this piece of paper. And the I know is not on this piece of paper. The I know is either something from a previous chapter or something in your brain, maybe something you have experienced personally or you've seen on a documentary like a PBS kind of show or a NASA kind of show. Then I predict or I wonder, okay? If you have all this information now, can we predict something that's going to happen in the next chapter? Can we predict what these things mean? Can we predict something new? Or I wonder, when you're learning about the seismic waves, the different types and how they move, and how we measure them, do questions pop into your head about these pieces of information? All right. Good job persevering with the growth mindset, and roar Wildcats!